All right, lesson 4.5, equivalent fractions. Again, very much review. I mean, you've been doing this since like third grade. So, nothing new. I will teach it though. Again, here's the deal. One of the types of questions, we're just going to go down the list here. One of the types of questions that they may ask is to tell you, it says write equivalent fractions. They have 6/8. An equivalent fraction is 6/8. What do they mean, an equivalent fraction? Do you guys all understand that? Look, fractions are always parts of a pie. You all know that, right? A fraction is always part of a pie. This right here is what? What have I shown you? What have I just showed you here? Jared, 3/4, right? This is also, listen, just because I take a knife out and cut more pieces, what is it now? What is it now? Now what am I showing you here? What am I showing you? I'm showing you 6/8. Did I add or take away any of the pie? No. It's still the same amount of pie. Do you agree? It's the same amount of pie. I just cut it into more pieces. Right? If I was to do it again, what is it now? 12/16. It's 12/16. Okay. Did I add pie? Did I take away pie? No, it's the same. They are the same fraction. They're equivalent fractions. 3/4, 6/8, 12/16 are all the same fraction. They all are equivalent fractions. Does that make sense? How do you know if two fractions are equivalent? How do you know if two fractions are equivalent? What if I have... How do you know if those two fractions are equivalent? What can you do to see if they are equivalent? Sladen?
See if, say, 7 divided by anything makes it into a 4.
Sure, that's one thing.
To see if the lowest number can divide it into a number.
No.
To see if 3 and 4 can be multiplied into a number.
Maybe. Let me tell you that here's the simplest way. If they're equivalent fractions, then they will both reduce to the same fraction. They will both reduce to the same fraction. 3/4, can I reduce 3/4 any more than it is? No. The 6/7, can I reduce that any more than it is? No. Therefore, since they're both reduced, are they the exact same fraction? No. They're not equivalent fractions. What about this? Equivalent fractions? You sure? What method did I just tell you to use to figure out whether or not fractions are equivalent? What did I tell you to do? What did I tell you to do? Reduce them just reduce them as far as they can be reduced. If they are equivalent fractions, then they will reduce to the same number, the same fraction. 10/25. How do you reduce fractions, by the way? How do you reduce fractions? Read.
You divide the numerator or the denominator by the same number.
What number do I choose to usually divide it by? You're going to take the numerator and the denominator and divide it by 1. This is very important. I'm going to divide this by 1. in the form of the greatest common factor over the greatest common factor. I'm going to say that again. I'm going to divide this fraction by 1 in the form of the greatest common factor by the greatest common factor. What is the greatest common factor again? What does that mean? We just did this yesterday. Please tell me you remember. What is the greatest common factor of two numbers? Momo, what's the greatest common factor of two numbers? Yes, more than that. What's the biggest number that the biggest factor that they both have, right? So in 10 and 25, what is the greatest common factor? Talking to Morgan. Does 10 go into 25? Okay. 5. I'm going to divide both the top and the bottom. When I divide something by this, listen, what is the difference between that and 10 over 25 divided by 5 over 5? What is dividing 5 over 5? By 1, right? That's why I'm allowed to do this, because I'm reducing the top and the bottom by the same number. And whenever I have the same number over the same number, what is that equal to? 1. You realize that, right? That 5 over 5 is what? 1. 7 over 7? A billion over a billion? The same number on top, same number on the bottom is 1, right? So I'm dividing this thing. I'm dividing 10/25 by 1 in the form of 5 over 5, the greatest common factor. What is 10 divided by 5? 2. What is 25 divided by 5? Okay, so it reduces to what? 2/5. Agreed? 10/25 reduces to 2/5. 6 over 15. What am I going to do? How do I reduce that? How do I reduce that, Michael? Divide both the top and the bottom, the numerator and the denominator, by 1 in the form of 3 over 3, right? Greatest common factor. Divide by 3, divide by 3. What is 6 divided by 3? What is 15 divided by 3? Oh. Are they equivalent fractions?
Yes.
Notice, people, most of you didn't think that they were equivalent because they didn't look like they were equivalent. I had 10/25 and 6/15, and you all said no. You were looking for the easy shortcut kind. What is the way to do this? What is the most efficient way of doing this? Divide. What is the most efficient way of deciding whether two fractions are equivalent or not? Read. Reduce them. If they reduce to the same number, then they are equivalent. If they don't, then they're not. Do you all understand what I'm saying? Yes, there are ones that are much easier than that, where they go, 6/8 and 12/16. And here, a lot of you would be like, yeah, they're equivalent, obviously. Why? How would you know? You realize that this is times 2 and this is also times 2, right? That they're. In the end, though, do you realize that they both reduce to 3/4, right? 3/4. You see that they both reduce to 3/4? Okay. You think that 6/8 is 1/2? Right? Okay. If I was to ask you this, do this for me. Write down two fractions that are equivalent to 6/10. Write down two fractions that is equivalent to 6/10. Yeah. Okay. Yeah, 3/5 works. 12/20 works. Okay. Simplify this. 20 over 28. Show me you know how to do that. We just talked about it. Okay, what do I do to reduce fractions, people? Oh, please tell me you know how to do this. What do I do to reduce fractions? Emily, what do I do? You said I put the greatest common factor. Subtract? Yes, you look for the greatest common factor. Then what?
But you use it
How?
by dividing it.
What did you do?
Divided by
You divided it, right.
no.
No. Okay, see, here's the deal. Listen. You take the fraction. You find the greatest common factor. What is the greatest common factor of 20 and 28? What is the greatest common factor of 20 and 28? 4. Divide, hold on, this is very important. I'm going to divide that fraction by 1 in the form of 4 over 4. Do you understand what I'm saying here? 20 divided by 4 is 5. 28 divided by 4 is 7. The answer is 5/7. I know, but if you can't articulate it, it doesn't do you any good. Something else, people, look at this. I'm going to show you this. And I know you all know this. What if you can't figure out the greatest common factor, or that's a pain for you? What could you do? How about dividing it by 1 in the form of
2.
any common factor, right? What is a common factor of 20 and 28? 2. It's always the easiest, right? When there's 2 even ones, you can just divide by 2. Divide by 2, divide by 2. That is 10 over 14. The only problem with doing it that way is that now you realize that you may still have more work to do, which you do, right? 10 and 14. What's another common factor of 10 and 14? 2 again. Divide by 2, divide by 2. 5 and 7. Now we're done. There's no more common factors between 5 and 7 other than 1, right? 1. Okay. Try another one. Try 24, 30 seconds. Reduce that, please. What did you do? Dylan, what did you do?
I found the greatest common factor of the 2 and divided it by
What is the greatest common factor?
8.
8. So Jared, what are you doing?
Yes.
What did you do? So you divided it by 8? No.
Or I divided it
By
1.
1 in the form of 8 over 8. Divide by 8, divide by 8. What is 24 divided by 8? 32 divided by 8? 3/4. What if you had decided to do this instead? What if you were like lazy and you were like, I see they're both even. I'll just divide this by 2. Is that okay?
Yeah.
12/16. Oh, they're still both even. Divide by 2, divide by 2. 6/8. Oh, divide by 2, divide by 2. Do you see why it's not quite as efficient? You know, it sounds like you're being lazy. It seems like it's easier just to divide by 2. Look how much longer that step is, right? Look how much longer it is. Here's the thing. I'm going to show you another way of dividing, okay? It's the same thing, okay? That same question, 24 and 36. Was it 36 or was it 32? It was 32. Watch. Write the prime factorization of 24. Is it not 2 times 2 times 2 times 3? Is it? Tell me. Ellie, is the prime factorization of 24, 2 times 2 times 2 times 3? Is it? Okay, you're right. What is the prime factorization of 32? Is it 2 times 2 times 2 times 2 times 2? See if that's true.
Yeah.
Is it?
Yes. Yes.
What is 2 times 2? Times 2? Times 2? Times 2? Watch what I'm allowed to do. Okay?
Okay.
What am I allowed to do here? You tell me. What am I allowed to do? What's the difference between that and 2 over 2 times 2 over 2 times 2 over 2 times 3 over 2 times 1 over 2? Notice what I've done. I've just kind of grouped them. You see what I'm talking about? What's the difference between this and this. What's the difference? Nothing. Okay. So then what is 2 over 2? 1. What is 2 over 2? 1. What is 2 over 2? 1. 1 times anything is itself. Do you agree? So this is 1 times 1 times 1. It's still 1. And then no matter what I'm multiplying it by, it's still going to, 1 has nothing to do with it. It's going to be whatever I'm multiplying it by. So these 3 times 3 halves is still, it's 3 halves, right? It's 1 times 3 halves, which is 3 halves. Agreed? And then what is 3 halves times 1 half? You guys remember how to multiply fractions? Tell me you remember how to multiply fractions. Is multiplying fractions easy or hard? What do you do when you multiply fractions? Oh, awesome. I think that tomorrow at lunchtime, we get to come in here. You guys have to know this. You're in advanced math. That's exciting for me to show you guys the basics of fractions. I'll just show you the shortcut, and then on tomorrow at lunchtime, I'll show you the long way. You're allowed to cross those guys out. And that leaves you with 3 on top. And what is 2 times 2 on the bottom? Do you remember when we figured out that 24 over 32 was 3/4? You remember that? This is another way. Try one. Try, do it any way you want to.
So we need to come tomorrow at lunchtime.
I would do the prime factorization way myself. At least here's the deal. This is what I would do. I would write out some factors. 36. I would go 6 times 6. Then I would go 12 times 10 down here. Do you agree that it's the same thing? That 6 times 6 is 36 and 12 times 10 is 120? Do you agree with that?
Yes.
Okay. Can I also break down the 12 and make it 6 times 2?
Yes.
Do you agree that I can do that? So I'm going to go 6 times 6 over 2 times 6 times 10. Have I changed anything? I mean, is there any difference between 36 over 120 and 6 times 6 over 2 times 6 times 10? No. I can cross out this, right? That leaves me with 6 over 20. Am I done? No, I'm not. So what could I have done? Let's go back to this back here. What could I have done? Could I not have gone, okay, this 6 is a 2 times a 3? I'll show you that again. Follow me here. Are you following me? Could I have made that 6 2 times 3 instead?
Yes.
Oh, okay. So 6 times 2 times 3 over 2 times 6 times 10. 6's are gone. The 2's are gone. What's that leave me with? Right? It's kind of a quick and easy way of doing it. The other option, class, the other option is for you to do it the longest way possible. And that is to go, okay, divide by 2, divide by 2. 18, first of all, some of you can't even do 36 divided by 2 in your head, so you'd have to write that out. 18 over 60. Okay, divide by 2, divide by 2. 9 over 30. Divide by 3, divide by 3. That becomes 3/10. I'm telling you. And that's if you're really good at this. If you're really good at this, then you didn't need to write all that stuff out anyway. But for those of you who did, you would have needed to probably divide this and go, okay, 36 divided by 2. You see how much longer that takes? It takes longer. Question, Mr. Campbell? Right, absolutely. That's another way of doing it, yeah. Right? Right? If you, right, I agree. That actually would be the best. 36 divided by 120. Divided by the greatest common factor. 12. You don't divide by 12. You divide by 1 in the form of 12 over 12, which is 3/10. So you're right. That is the way to do it. But here's the problem, you know.
That's a big number.
You see what I'm talking about? All of a sudden, do you really want to be doing that? You know, okay. Right? I mean, sometimes they're not simple to do. Sometimes they're not as simple to do. Okay? That's really it, people. I think you should be able to do this. We'll see. We will see.
So do you still need to come?
Oh, yeah, we'll talk about it in a second.